Good evening, everyone. Welcome to the June meeting of the Fort Worth Astronomical Society. I am your president, Chris Modnitsky. This is our, fourth virtual meeting now because of COVID-19. So we are still meeting over YouTube because we cannot meet in person. Well, we've got a lot of stuff to cover today. So we have to talk about club elections. We have a presentation. We have our general astronomy events, talk a little about the club, some of the club business specifically to do with star parties, and I've got something to show everyone. So let's go ahead and get started. Jump off. Here we go. So again, welcome. It is the June 16th meeting. So let's go ahead and just get started. Okay, who is the Fort Worth Astronomical Society? So we've been around since 1949. We were started by Miss Charlie Mary Noble, for whom the Noble Planetarium at the Fort Worth Museum of Science and History is named. We are one of the first adult amateur astronomy clubs in the country, and we are one of the largest astronomy clubs in the U.S., and we have, I think we're at 143 members right now, individuals and families. And since 2014, we have been a 501c3 tax-exempt organization. So if you give us any money for dues or donations, you can remove those from your taxes as a charitable contribution. So our mission to actively promote the science of astronomy through outreach and education, such as free public star parties, other public events, museum presentations, and school presentations. To encourage and coordinate the activities of other groups interested in astronomy, to foster observational work and research among our members, and to foster craftsmanship in the construction of astronomical instruments, and to make those instruments available for the use of our members to the extent possible. The Fort Worth Astronomical Society was formed for educational and scientific purposes for all individuals and all groups, for the primary purpose of developing and implementing programs designed to increase the awareness and knowledge of astronomy for all interested individuals, but specifically for those living in and around Tarrant County, Texas. Providing the opportunity for those individuals to pursue the science of astronomy in a dark sky observation site using club-owned equipment, and providing an opportunity for all club members and guests to share their experiences and discoveries. So again, welcome to our June virtual meeting, courtesy of COVID-19. Remember, wash your hands, don't touch your face, self-quarantine as much as possible, and wear a mask when you are going out. The numbers keep increasing. And this past weekend here in Texas, we've had the highest spike in new cases since March. So it's not a good thing. Please, please, please wear a mask. Be careful. Wearing a mask reduces your the chance of you getting exposed by, I think it's like between 40 and 75% now, depending on the mask, depending on a bunch of factors, but it is better than no mask at all. We have two dark sky sites. We have one in Wise County at the Thompson Private Nature Reserve. We have a number of telescopes out there, we have power, and we have a very lovely toilet out there. However, currently the Thompson site is closed to all visitors, so we cannot use that one. The Stevens County Star Range site, we have a 19-inch scope, we have a number of others out there. There is power, there is solar power and batteries. Like in the picture, bring your own. We do have a composting toilet out there, but there is no water, therefore no campfires, no open fires whatsoever. We do not want a wildfire out there. Currently, we do have some regulations as to behavior out there. Stay far away from each other, minimum 10 feet, don't share equipment, don't look through somebody else's eyepiece, wear a mask if you're going to be near people, things like that. It just the regular common sense suggestions that we've been doing for the last several months now. Okay, all public star parties have been canceled. We don't have anything going on right now. Recommendations are to have no large groups to minimize exposure and spread. As soon as we have something. We will start doing them again. And at Tandy Hills, there are no plans for any star parties at this time, and no plans for, oops, I didn't finish that, no plans for anything in the future, possibly into the fall. The numbers keep increasing. That means that there's more exposure. And one of the issues that we have at public star parties is we have a large number of people in a fairly small area close together. It's dark. You may not see that there is someone directly behind you. Probably feel it, but you may not see it. And when you're looking through a telescope, you're looking through a little bitty eyepiece, and you looking at it and probably touching it with your face, the next person's going to come by and they're going to do the same thing. Well, now they've gotten some of your germs onto them. And you go to the next telescope and do the same thing, and that's how it spreads. We have talked about perhaps doing something with video astronomy, where an electronic eyepiece or a camera can be connected to a laptop or a monitor. But again, the issue you have is it's a small screen, and you're going to get people crowding around it anyway. So at this time, we're not going to be doing any star parties. We are doing the virtual events. So we have the YouTube channel and the Facebook site. So if you would like to keep updated as to when we're doing star parties, please subscribe to the YouTube channel, like and subscribe, the usual thing. And you can go ahead and sign up and like the Facebook site as well. You will get updates. I try to do usually 2 to 3 days ahead of time for the star parties, so there's at least a little bit of lead time. There's something I'm going to talk about later specifically about this. So, upcoming astronomical events. June 20th, we have the June solstice. This is the longest day of the year, the shortest night of the year. Not a great time to do astrophotography because you just don't have that much time. But the summer Milky Way is out. So there's a lot of neat stuff to see, but it doesn't get dark until pretty late. So you pretty much have to get out there and just wait and wait and wait. And by the time the sky is really dark enough, it's already going to be 10 o'clock. June 21st, we have an annular solar eclipse. So this one is when the moon is a little bit closer to the Earth than normal, and it doesn't cover up the entire face of the sun. This will not be visible in the US. It'll start in Central Africa and travel through Saudi Arabia, India, and southern China, and then ends up in the Pacific. And you can see a partial eclipse through Eastern Africa, the Middle East, and Southern Asia. We're not going to see anything here. It'll be nighttime for us, so oh well. And, of course, because it is a solar eclipse, the same day we have a new moon. So this is a good time to go out to the dark sky site, and or one available one, and go ahead and you can see. So the moon will be a very, very, actually no, because we have the eclipse, you will not see the moon. It will be a very, very young moon that night. So the next couple nights are actually pretty good for going out and doing some astrophotography or just doing some observing. Because on July 5th, we have a full moon. And we don't like to go out when there's a full moon because it washes everything out of the sky. This full moon was known as the buck moon because the male buck deer would begin to grow their new antlers, and the thunder moon and the hay moon. And on July 5th, the same day, because it is a full moon, we have a penumbral lunar eclipse. We just had one last month as well. That one was not visible to us. That was visible only to the Eastern Hemisphere. So this one will be visible to us. We will see it in most North America, South America, and the Pacific, and the Western Atlantic, and extreme Western Africa. So we will be able to see that one. It is not a blood moon. This is a penumbral lunar eclipse, so this is a partial shadow. The moon will get slightly darker, and that's about it. And if you haven't really been paying attention, you may not even notice. So that is, again, July 5th. July 14th, we have Jupiter at opposition. So this is when it's closest to the Earth. It means it'll be fully illuminated. So the entire face of Jupiter will be lit up. You won't see this little shadow area off to the side. You'll be able to see it all night long. And we should be able to get some good views. I will try to do a star party around this time. I want to get Jupiter and I want to get Saturn. We have not seen those at our virtual events. So I want to go ahead and try to grab those. And on July 20th, we have another new moon, another good time to go out and look at the night sky. Also, July 20th, we have Saturn in opposition. So it's the same as Jupiter. It's going to be directly in line between Earth, the Sun, with the Earth and the Sun. It will be the brightest it's going to be for a while. So it is a good time to go observe it. So I'm not sure what the rings are doing this time. Sorry, I don't know what the rings are doing this year. We'll find out. But they should be pretty visible. And yeah, we'll see what we can see. But I want to plan a star party around that time so we can catch Jupiter and Saturn at the same time. Do some planetary stuff. June 4th. Oh, sorry. This should be. Ooh, I don't have the date right. Didn't change the date. Nuts. Okay, so this is, if I remember, July 21st or 22nd, I think, somewhere right there. Mercury is at greatest western elongation, so what that means, it's going to be visible at sunrise in the east. So it'll pop up over the horizon, and if you look at it just before sunrise, you should be able to see a little bright star-looking thing right above and to the right of where the sun pops up. So again, find out when sunset is, and then look ahead of time at a place where you can see the horizon. July 28th and 29th, we have the Delta Aquariids meteor shower. So it's an average shower. It's not usually a big one, but it'll produce up to about 20 meteors per hour at the peak. And remember, the peak is always after midnight because the Earth is now moving into, or sorry, the point on the Earth where you are is now moving into the stream and not away from it. So you're getting more meteors at that point than earlier in the night. So again, after midnight is the best time to observe. So it's on the night of the 28th and 29th, and there will be a second quarter moon. Second quarter is when it comes up well after midnight, so it will wash out some of the faint ones, but at least you'll be able to see something, hopefully, if it's not cloudy. Okay, we've had some really, really good weather lately. We've had some really nice clear skies, and I just have not had the opportunity to do anything. I've been incredibly busy the last 3 weeks, just working late, trying to get so much stuff done. So we'll talk about that in just a bit as well. If you have any photos, if you have any articles, please go ahead and send to George Lutch. He is our editor for Prime Focus, our monthly newsletter. And now we have a presentation. This is from our member Dan. And let's see if I can get Dan in. Bear with me, everyone. Let's see. Okay, Dan, are you ready? Okay. And let's see. Hold on. This is fun, isn't it?
Oh, it's grand time.
Okay, here we go. And Dan, let's see. Dan, I should be able to hear you. Can you hear me?
Can you hear me?
I can hear you.
I'll start in a second here.
So,
I can start anytime. Just nod your head.
you know what?
Give me the high sign.
You're ready to go.
Okay. Good evening. My name is Dan Cotto-Thorner. I'm relatively new to the Fort Worth area. My family and I moved down back in 2017. We escaped from Illinois, and have been interested in astronomy since I went to the University of Arizona some decades ago, and I really don't want to remind people how many decades ago that was. But one of the things that has been of interest to me lately is calendars and how we identify them and how we track things and how different they are and how unusual some of them are. So I wanted to offer my meager knowledge on that, and hopefully we'll all learn a little bit more about calendars, and we'll go from there because there's a lot more that I am not going to be able to cover tonight. Essentially, in our world, there are four different types of calendars. There's the solar, which is based on the movement of the sun, lunar, which would be based on the movement of the moon, lunar solar, which is a combination of the two. You'll see in a minute here, some of you may be aware of how there's a linkage between the sun and moon as far as calendars go. And there are a number of calendars that use a lunar solar method. And then there's other calendars, which some of which ignore the sun and the moon entirely, and like the Julian calendar, the Mayan calendar, which Chris went over in the last presentation, and he did a great job on that. And that's an example of a calendar that is kind of outside this. Yes, it was based on part of it was based on the sun, but there's also that 260-day cycle and that 13-day cycle, and it gets kind of strange. I'm not going to be going into the Mayan calendar, but because there's plenty of other things that we can look at this evening. In general, again, the four different types of calendars are solar calendars, usually marked by the sun returning to the same place. Example would be the winter solstice, the vernal equinox, the summer solstice. I don't know of anybody who uses the autumnal equinox as a starting date for a calendar, but it's possible somebody does. But those are common ones. It is usually linked to the seasons. Generally, the moon is unimportant in determining when you begin a year. You're looking for the sun to be at a certain point, and that's what your focus is. Three prime examples are, of course, the familiar Julian calendar, which set up by Julius Caesar back in 46 BC. The Gregorian calendar, which is the modified Julian calendar, which we'll talk a little bit about later. The Iranian calendar, the nation of Iran uses a different calendar system, and they base it solely on the appearance of the vernal equinox. And so they reset things every year on that. And that's an example of one. They just use that particular date, and that's it. Another form is the lunar calendars. It's based on the appearance of the moon in a particular location in the sky. By that I mean usually it's visible when you could first see it after a new moon, though there are some places that have used a full moon as a means of determining that. There probably are places that use the disappearance of the moon, but I did not find any offhand in my research. As you're probably well aware, the lunar calendar is not in any way, shape, or form synced with the 1 year that we have. The number of new moons per year varies between 12 and 13, and there's not much you can wind up doing with that. Additionally, the months are not set of the same length. It's about 29 and a half days for a lunar orbit, and so your months can be 29 or 30 days. Generally, and the best known example of this is the Islamic calendar. We'll go into that a little bit later, but that's one that I think many of us are familiar with through news and through personal faith, perhaps. The lunar solar calendars are ones that are much more accurate than the lunar calendar as far as keeping it in sync with the year. The moon and sun are set in a pattern, amazingly enough, that is somewhat odd. It's 235 lunar months equal 19 solar years almost. There's a 2 hour, 3 minute, and 50-second difference between those over a 19-year period. That does fluctuate a little bit, but generally that's the number that you're looking at. And that adds up to roughly 1 day every 209 years, which actually makes it more accurate than the Julian calendar, because the Julian calendar, as you know, is accurate only to about it loses 1 day roughly every 130 years. So the lunar solar calendars can be extremely accurate, and there are a number of them that are used. And I didn't put the typically there. I didn't fill that in. Years are typically 12 or 13 months. An extra month is inserted as needed. There are certain patterns. We'll see those a little bit later as we go through this. Some of them have the patterns set up very religiously, as it were. The best example on this is that we're probably familiar with is the Hebrew calendar, the Jewish calendar, which is a lunar solar calendar. They have some extra things thrown in that make it somewhat a little bit different than a typical lunar solar calendar, that they have to make modifications for religious purposes. And so we'll talk about that. I'm going to only be focusing primarily on the calendars of the Western traditions, primarily because the calendars in the Eastern traditions are much more complex. Some of them have some very unusual things that fall outside what we would normally use or familiar with. But our calendars, the ones that we're familiar with, pretty much come out of the Western tradition. Starting with the Egyptian calendars. There are actually two sets of calendars in ancient Egypt. Ancient Egypt wound up with two separate calendars, but they ran them simultaneously. One of them was a solar calendar based on the appearance of Sirius. Some of you may be familiar with the fact that the appearance of Sirius in the early morning presets the rising of the Nile. So the Nile floods will appear not long after the rising of Sirius in the morning. And so what you have is people anxiously looking for the appearance of Sirius. And so when it shows up, that's great. That means the floods are going to be on their way. And that was pretty much set every year. They were looking for it, and they knew that it was roughly 365 and a quarter days. They were not unfamiliar with that, but they did set up a civic calendar, and they really didn't care about that extra quarter of a day. They pretty much ignored it. So the civic calendar was 365 days a year. There were 12 30-day months and 5 days for the gods. And they knew that they were losing 1 day every 4 years, and that they lived with it. That was not a big issue from their perspective. They just knew that that's what they were going to have, which led to something called the Sothic cycle. The Sothic cycle is something where Sirius and New Year's Day appear on the same day, and then how long it takes to recycle through. That's roughly 1,440 years. So it's something that can be calculated, and people can use as a point to identify when certain things happen. So if there's a etching on a wall someplace that says in the 7th year of King Tutmos, you had Sirius rise on the 4th day of the 7th month. That gives you a pretty good idea of exactly what year that was, give or take 4 years in our calendar, because in 139 AD, somebody, a Greek astronomer in Alexandria, set that and identified when that was. He set up a specific date, and you could link back from there. There is something called the Tablet of Djer, which is one of the earliest writings in Egyptian, and it has Sirius rising on the 1st day of the civic year And if that is correct, then that happened on July 17th in 2774 BCE. So that's a good way to calculate things back. There are maybe half a dozen mentions of Sirius appearing and the date linked to that. But the Egyptians were very conscious of it, and they certainly understood what was going on with the calendar on that particular um, with that particular cycle in mind. Babylonians were also great astronomers. They spent an incredible amount of time working on these things, and they've got some incredible math that's gone on in other ways. Their mathematical skills were outstanding. But they based their calendar on a lunar solar calendar. They identified it, what we would call the Metonic cycle, around at least in the 12th century BCE. That was known to them by that time. We call it the Metonic cycle because a Greek um, uh, writer named Meton described it, and that was what we knew about it before the discovery of Babylonian scripts and the decipherment of cuneiform. So we didn't know that the Babylonians had actually discovered it much earlier. The Babylonians figured out a way to regularly schedule 7 extra months every 19 years, and that kept their calendar in pretty good organization. It did influence the ancient Greek calendars and also the modern Hebrew calendar, which again we'll go over a little bit later. But generally, they added the extra month in years 3, 6, 8, 11, 14, 17, and 19. Those are the years that had the extra month added to keep the calendar in sync with the sun. So they were pretty good with that, and they passed their information on to the Greeks. Unfortunately, the Greek. Oh, and this is another item that I discovered. I don't know if you've been to Berlin or are familiar with German history. There's this thing called the golden hats, and there's some people who believe that these golden hats, which are amazing, the one on the right is about 3 feet tall and weighs under a pound, and it's 90% gold. It's absolutely amazing. It was made somewhere around 1500 BC, so it's 3,500 years old. And there's some people that believe those circles and the lines can be used to calculate, also used to calculate the Metonic cycle. And that means that somebody in Germany 3,500 years ago was able to figure out that every 19 years the sun and the moon lined up again, which the mathematics involved in that is quite astounding when you come right down to it. I'm sure most of us don't pay attention at all today as to where the moon's going to be 19 years from now, or can remember where it was 19 years ago. But these people, if this indeed does deal with that, it's quite an astounding feat that they were able to calculate that. However, the Greeks, who took this information from the Babylonians, were not as organized as the Babylonians were, because every single Greek city decided to have their own calendar with their own names and start the month whenever they pretty much wanted to. So Greek calendars are not always the most helpful things that we have available in trying to figure out when events occurred in the past. Every city had its own calendar. Every city had different names for every month. They had different start dates. Usually it was the sighting of the first moon, but if it was cloudy and the city of Athens said, yeah, well, we're going to go ahead and count this being the start of the next month, and Megara said, no, we're going to wait until we can actually see the moon, then those months got out of sync. However, this does come in handy in at least one case. You may be familiar with something called the Antikythera device, which was the calculator that appears to have been made sometime, astronomical calculator that was built sometime in the 1st or 2nd century BC. And based on decipherment of the writing on the Antikythera device, it appears that it was made by somebody who either came from Corinth or one of its colonies, because the months that were listed are Corinthian months. So that at least provided some information as to the where this thing came from or who might have been involved with it. But again, every city had its own calendar, and every city pretty much decided what year was based on whoever was ruling the city at the time. If they had a new ethnarch that particular year, or whatever they happened to call their leader, then they'd wind up they'd identify that as the means of what year it was. They would not necessarily, they didn't have a structure to hang things on and say, oh, that happened in 79 years ago. They'd have to actually count backwards and figure out who was running things at a particular time. So this is something that you see frequently in the ancient world. It wasn't really until the early Christian era that people were interested in finding out what a year one was. And we'll get to that in a little bit here, but that was one of the things that was an advancement as far as keeping track of time was concerned in the ancient world. Romans. The Romans, who we normally imagine as being brilliant engineers, well, they were not particularly good with calendars. Their calendar initially, now we're talking roughly 750 BCE, their original calendar was not lunar, was not solar, was not lunisolar, it was just kind of there. They had 298 days, 10 months starting in March, and that's why the 9th month of the year in our current calendar is named 7. Some of you may have wondered that at some point in time as to why September is the 9th month, and that's because at one point in time, Rome only used 10 months, and they started with March. And the first 4 months were dedicated to gods. March was dedicated to Mars. April might have been dedicated to Apollo. There's an argument as to who it actually was dedicated to. May is dedicated to the Greek goddess Maya, and June is dedicated to the Roman goddess Juno. And then you had months 5, 6, 7, 8, 9, and 10. July and August were not renamed until much later. I'll get to that shortly here. They had their year broken into 2 different types of months. There was a 31-day month, which they called full, and a 29-day month, which they called empty. And so that's why you wound up with 298 days. And the priests would decide when the year started. There was a priest who was called the Pontifex Maximus. And yes, that was the chief priest at the time. Julius Caesar was Pontifex Maximus. And those of you who are familiar with your religious history might say, hey, that sounds an awful lot like one of the titles of the Pope. And it is, yes. But Julius Caesar was Pontifex Maximus. And in fact, that's why he, at one point in time, wound up adjusting the calendar, because he was sick and tired of it being very messed up. It was the Roman king, one of the Roman kings, Numa Pompilius, who added January and February, but he did not add them so that you wound up with a nice, normal 365-day calendar. You wound up with a calendar that occasionally was like 355 days, and every once in a while they would stick in a month called Mercedonius after February 23rd, and there's a reason for that, which we'll get to in a minute. And they added that occasionally to make sure the calendar got in line so that March didn't happen in the middle of winter or near the summer solstice or whatever. They just would throw that in occasionally based on what the Pontifex Maximus decided. Roman dates are also somewhat confusing. Their years were identified by consuls. They were not looking at a year one all the time, though they did occasionally refer to ab urbe condita, AUC, which meant from the founding of the city, which would have been, of course, Rome, which they, if they calculated back, was in 754, in our calendar, 754 BCE. So they worked their way back and calculated that, but it was not in official documents. Official documents would be based on who was the consuls for that year. So if Caesar and Bulbus were the consuls, that's what you referred to. The senior consul came in first. Days of the month were somewhat convoluted. They looked at the month and they broke things out based on three set days. Every month had the calends on the first, and that's where we get our word calendar. And oddly enough, it's one of the few words in Latin that actually had a K in it. I actually have also studied linguistics, so it's kind of funny that you see something with a K in it in Latin. Usually they use the letter C for the K sound. But anyway, they had calends was the first of the month, of the next month. The nones was the fifth or the seventh, and it would be the fifth in an empty month and the seventh in a full month. And the Ides, beware the Ides of March. Well, that happened on the 15th because March was a full month. And whereas June would have been a empty month. So it would have had the Ides on the 13th. Dates were inclusive, and this comes to haunt them a little bit later when they're trying to get some things done. By that, I mean, if you work things out today, June 16th in our calendar is 16 days before the calends of July. Now, I'm sure a number of you are sitting there going on your fingers, July 1st, June 9th, 29th, and working your way backwards. And you're sitting there going, no, it's not 16 days. Yes, it is, because the Romans included the calends as the day, and they include today as a day. So when they worked their way back, it also included the first day of the next month. This is kind of a strange way of doing it from our perspective, but it worked for them for 800 or 900 years. So I guess it does have, it is something that does work. July, of course, did not get its name until after Julius Caesar was assassinated. It was named after him by his nephew Augustus. And Caesar Augustus had the month of August named after him by the Senate in 8 BC to honor Caesar Augustus. And he decided to make August the the eighth month of the year, named after him, primarily because that's when many of his victories came. That's when he defeated Mark Antony, and that's when he took over Egypt and some other things that he did. So he decided to use that as a month to honor him. Other Roman emperors tried to add other months to their names, September or October. September, they never stuck though. They all failed, and so we wind up with July and August, named after the first two Roman emperors, and then none of the other emperors managing to get names in our calendar. Mercedonius, that 27-day month that they stuck in every once in a while, was added 6 days before the calends of March, which we would call February 24th. And it would just run from that point forward so that they wouldn't actually insert it between the February 24th and February 25th, what we would think of it as that. They just had the 27 days added there. And again, it was up to the priests to add it. And if they didn't add it, the calendar got way out of whack. And it got so badly out of whack that Julius Caesar said, that's it, we've got to fix it. So in 47 BC, after Julius Caesar had finished taking over everything and pretty much organizing things in Rome under his liking, he set up a um, a, a program to look into fixing the Roman calendar. Because of civil wars, there was a huge civil war, of course, with Julius Caesar, but there was also another one just 30 years earlier than that that messed up calendars as well. And so the calendar was very badly out of date. When Caesar was in Egypt, with Cleopatra, he decided to hire a Egyptian, or excuse me, an Alexandrian mathematician, Sosigenes, and he brought a team over to Rome to fix the calendar so that they could get the thing into a nice, formal, organized pattern. To do so, they had to have 446 days in 40, what we would consider 46 BC. They added 3 extra months, first Mercedonius, second Mercedonius, and third Mercedonius, to bring things into order. So they finally calculated it out, and Caesar was able to get the whole idea of a leap year, a leap day added, and it was added in the same place that they had put in Mercedonius, which was the 24th of February. So you actually had two 24ths of February. You had first 24th February and second 24th February. That was just the way they did it, and it worked like that for about 600 years. Leap years as a whole were actually thought of within Egypt, primarily during the Alexandrian, the Ptolemaic reign out of Alexandria. Ptolemy III wanted to create a leap year every 4th year to honor him and his wife. It was not approved by the Egyptian priests, and so he just kind of backed away from it. But it was something that certainly people understood. They thought they knew about it, and the idea of adding an extra day every 4 years to keep the calendar close to being normal was something that certainly the mathematicians of the day were well acquainted with. The Julian calendar, again, I mentioned it was adding a day after, or on February 24th. The festival of Terminalia was a major festival in February, and that was where they decided to stick the extra day. However, inclusive counting caused some problems. I mentioned before that they included the first and the last day in a series of dates as part of the counting. And so when they said, oh, we're going to have a leap year every 4th year, that meant that if this was a leap year, next year, 2021, would not be a leap year, and 2022 would not be a leap year, but 2023 would be a leap year because that was the 4th year. If you count this year and 2023. That caused problems because it knocked the calendar out of whack very quickly. Fortunately, Augustus saw the problem and had leap years canceled for 12 years until they got the calendar back on track. And then after that, the Julian calendar stayed pretty much the same until today. There are still people who use the Julian calendar. The Greek Orthodox Church, or the Orthodox churches, use the Julian calendar. For over 2,000 years, that's been pretty much the pattern that exists in that calendar. So Caesar and his team did a pretty good job of setting that thing up. The Gregorian reform of 1582, I do want to point out, people were aware of the fact that there was slippage. They understood that there was a problem. As early as the 5th century AD, people were aware of the fact that there were days appearing because we'll get to it in a minute here, but Easter is an extremely important date within the Christian calendar. And they use Easter's is set based on the appearance of the vernal equinox. And they started noticing that the vernal equinox was getting out of whack. as far as they expected it around March 21st, but it was moving because there were extra days appearing there, and so it was not happening when they expected it to happen. And as I said, as early as the fifth, sixth centuries, they people who were setting Easter up as a date were acquainted with the fact that there's a problem occurring, but nobody wanted to do anything with it until Pope Gregory in 1582, when they determined that the best way to handle that would be the Gregorian reforms. They removed leap days in years ending 00 unless they're divisible by 400. So, for example, 1900 was not a leap year, whereas the year 2000 was. And so 2100 will not be a leap year. This pattern was adopted within the Catholic Church. The solution was to actually eliminate, at the time, it was 11 days out of sync with where they wanted Easter to be. And so the solution was to eliminate those 11 days back in 1582. The Protestant communities, so most of Northern Europe, and the Orthodox communities, most of Eastern Europe, pretty much said, no, we're not going to go with the Gregorian calendar. And so it took some hundreds of years for the calendars to get back and synced up across Europe. England did not accept the Gregorian calendar until 1752, and the Soviet Union did not accept it until 1918. So they were still going by the Julian calendar until the Russian Revolution. So the reforms are there, but it's taken a long time. Took a long time for everybody to accept them as being the norms on that. So let's look at some specific calendars. One calendar that we're acquainted with is the Islamic calendar. It's purely a lunar calendar. It's expected on the next month starts when the new moon is seen. Now out in the desert, it's pretty straightforward. Not major problem in identifying the new moon, but in other places it can be a potential issue. It's primarily used for religious purposes nowadays, but it is something that's important. It does rotate through the year. There are 354 or 355 days per year, and the year rotates through the season. So roughly in a 33-year period, any particular holiday within the Islamic tradition will wind up appearing in every season as it rotates through. There is no official governing body to set the calendar, unlike the Christian churches, which have two different bodies, and we'll talk about that a little bit. But so there can be some problems in syncing things up, but if there's a need to be absolutely sure about something, the calendar that's used in Medina would probably be the one that you would want to refer to. Again, officially, the new month begins on the day of the new moon. It's often in certain environments in certain countries, what the local community will do is just say we're going to alternate between 29 and 30-day months, regardless of whether we actually see the moon or not. Again, it's up to the local community to make that decision. Effectively, months alternate between 29 and 30 days. Generally, within the Islamic world, the civic calendar that's used is the Gregorian calendar, with some exceptions. I mentioned Iran having its own calendar, and some other, Afghanistan, I believe, uses the same one officially that Iran uses. The Hebrew calendar. Many of us are probably acquainted with the Hebrew calendar. I grew up in New York, where, believe it or not, it was everybody was pretty much familiar with both calendars, simply because I got the holiday of Rosh Hashanah off every year in school because so many of our teachers were of the Jewish faith that they just canceled school. So when I moved to an area that was not as heavily Jewish, I was wondering why we didn't get Rosh Hashanah off as a holiday. So it's just one of those things. The Hebrew calendar uses a lunar solar calendar with a couple of minor adjustments. All the months are 12 or 13, or I mean, there's 12 or 13 months in a year, and they're all 29 or 30 days long. They usually alternate 29 or 30 days, but there are 2 months, the 8th and the 9th month, can have 29 or 30 days, and there's a specific reason for that. The year can actually be, there's 6 different lengths of a year possible based on what the calculations are that are necessary to keep the calendar in sync. So a year can either be from 353 to 355 days long, or 383 to 385 days long. Why? Because there are certain requirements that absolutely must happen within the Jewish faith on this. Passover has to happen after the vernal equinox, and Yom Kippur cannot fall on a Friday or a Sunday, and the last day of another holiday, the Festival of the Tabernacles, cannot fall on a Wednesday. So to make sure that these things happen, the 8th or the 9th month can either have a day taken or added so that these 3 criteria are met for every year in the calendar. And that's why you have some slight variations, but generally you'll have Rosh Hashanah and Yom Kippur fall in September, and you'll have Hanukkah fall in December, typically between the second week and the last week of December. Days are added and removed, as I said, to meet these rules, to make sure that there's no problem with it. I found this interesting. I mentioned I've got some linguistics background as well. The earliest written Hebrew is actually a calendar from the 10th century BC, and it talks about how to set up the calendar. So even 3,000 years ago, one of the most important things that they had to set up was a calendar. And it actually has a calendar that appears to be starting in September, like the current Jewish calendar does. So they've kept things organized for 3,000 years, which is really quite amazing when you consider the level of work that goes into a lot of this stuff for calculating these things. Setting Easter. Now, this is something that I know you may not be aware of. You just know that every year you're going to wind up with Easter. Easter actually has a very rigid set of requirements for setting it. And it was something that caused some consternation in the past. Much like the Hebrew calendar, Easter is extremely important within the Christian traditions, and so they have to deal with certain issues on that. It was originally tied to Passover. It would be the Sunday after Passover, and that's how it was scheduled. But with the calendars getting out of sync, and then also another problem that was noticed was the spread of Christianity across Europe. Now, traditionally, it was the first Sunday after the first full moon after the vernal equinox. Makes perfect sense. But it's a problem, because when is the exact full moon? If you're in Jerusalem, you're 4, 5, 6 hours ahead of Dublin. And which day does, if the full moon happens sometime between Saturday night and Sunday morning, which day is the full moon occurring on? Because if it happens on a Sunday, then Easter's supposed to be the next Sunday. It's not, you can't have Easter on the Sunday of the full moon. Whereas if you're in Ireland, well, that's later, and so the full moon occurs on Saturday, so the next day is Easter. And believe it or not, you have a lot of conflict within certain elements in the Christian church as to when exactly Easter was. based on where you were located. And so eventually the Roman Catholic Church determined that the vernal equinox is on March 21st. Thank you very much. We're done. We're not going to argue the point. We know it fluctuates a little bit, but we're just going to set it on March 21st. And the Protestants pretty much followed along with this within the community. But the Eastern Orthodox Church, or the Orthodox churches, mostly in Eastern Europe, did not. They stuck with the Julian calendar. And because the Julian calendar is 13 days out of sync with our calendar, their Easter is going to wind up being at a different time because they say it's on March 21st, and that would be at a different time from March 21st within the Gregorian calendar. So the two calendars are 13 days out of date right now, and are out of sync. And so it's not uncommon to have the Orthodox Easter occur anywhere between 3 and 5 weeks later than the um, Western calendar, the Gregorian Easter does. So when is year one? We've talked about that. I've mentioned years going back and forth. How do you determine what is year one? Well, let's look at our determination. The AD, or the Common Era. A Greek scholar living in Constantinople in the 6th century worked it backwards to calculate when Jesus was born and started using it within his documentation. The reason he did that is because he didn't like using at the time they were using the first year of Diocletian as the baseline for their years. And Diocletian was very much anti-Christian, and this Dionysus fellow, decided he did not want to use that as a baseline to calculate Easter. But there's no details as to how he came up with it, how he came up with the date. So it was pretty much ignored within the Byzantine Empire. Oddly enough, though, monks in England started taking it up in the 8th century, in the early 8th century. And when Charlemagne became the king of, or the emperor of the Western Roman Empire in 800 AD, he actually brought in a bunch of monks from England because they were the leading scholars, and that started using those dates in his calculations. It was something that was just that his team used, that anybody who was in the Western Empire under his authority would use those as a date, and it carried on from there. So you can blame the English for that one. Actually, if you're familiar with a place called Lindisfarne or the Venerable Bede, those are some of the people that would have been involved in calculating this and using it and spreading it to just about everybody now. But the Byzantine Empire, which was running out of Constantinople, didn't bother with that. They actually had their mathematicians work things out, and they determined that the world was created on March 25th, 5493 BC, what we would call 5493 BC in our calculations. How they came up with March 25th, I'm not quite sure, but it's a handy date to use. And that's why, believe it or not, up until the 18th century, there were many nations that used March 25th as the first day of the year. It was common. If you do genealogies, I ran into that as the first time I ran into it actually was when I was doing genealogical work for my family, and I kept seeing these dates that said, February 7th, 1723-24, and you're like, what do they mean by that? They can't figure out which year it was, and it depended upon what year, when the first of the year was. Anyway, based on this, we're in year 7528. And I don't know, maybe that's actually probably not a bad way of calculating things. Just we're 7528. Sounds cool. Again, it was not replaced completely until the 1700s in the Byzantine Empire, and in the Orthodox Church. You had documents dated using the Anno Mundi calculation well into the 1700s. So, but it's no longer used in that environment. Let's see. Islam uses the year of the Muhammad's flight to Medina, and that's Medina, and I spelled it wrong, not media. He did not go to media. That was calculated by the Caliph Umar about 18 years afterwards, and it was the equivalent to our year 632 Common Era. The Hebrew calendar is also based on a calculation of the creation of the world. A famous Hebrew scholar named Maimonides calculated it at 4,938 years before him in 1178. And so this year is 5780 within the Hebrew calendar. And there's one final thing that I want to look at here. It's something called the Julian period. I'm sure many of you, if you've looked in astronomical documents, you'll see the Julian date listed. And it does cause some confusion. I know in business environments, you'll frequently see something that says Julian date, and it's the day of the year. So this is June 16th. I don't know, this is what, maybe 142 or something like that for this year. That's not what the Julian date was. The Julian date was something that was calculated back in 1583, or was started back in 1583, not right after the Gregorian calendar was implemented, because there were astronomers who were concerned that when you wound up changing the dates, you're losing an 11-day period, and it can really mess up your calculations. You're trying to see exactly where something was. You're calculating where Mars is going to wind up being, or whatever, and you have this 11-day gap, and it's going to be a problem. And so I'm sorry, I did not get the gentleman's name. I forgot to put it in, but it was a monk from in Rome that calculated this, and it was based on 3 concurrent cycles that were used at that period of time. Much like the Mayan calendar that Chris discussed last week, imagine, if you will, 3 wheels that are interlocked with these 3 cycles, and you have a 28-year Julian cycle. And that means that in the 28 years, every block of 28 years looks exactly the same. With the leap years and all that other stuff working its way through it, every 28-year block looks exactly the same. Likewise, you have the 19-year lunar cycle, and then in the Middle Ages, you had something called an indiction. I can't understand why they came up with it, but it was something that they found was useful, and it was a 15-year cycle that you would typically use in linking up the reign of a particular monarch with the year cycle that you're dealing with. They weren't using AD or the Byzantine years. They were using this 15-year cycle. So you might say in the 3rd year of King John, in the 7th indiction. And that meant it was in the 7th year of this 15-year cycle, and it happened to coincide with the 3rd year of the reign of King John. So the 3 of them will cycle through roughly every 7,800 years. If you treat the 28-year cycle, the 19-year cycle, and the 15-year cycle as 3 separate cogs in a wheel with a number of days that line up, It's a very lengthy period, and it gives you a starting point that's way back in the past, and that's 4713 BCE. So that gives you an opportunity to sit back and say, we're just going to count the number of days since January 1st, 4713 BCE, and that gives us a chance that we're going to ignore the year, we're going to ignore the lunar cycles, we're going to ignore all that stuff, we're just going to count days. So if you pick up a copy of Sky and Telescope, there'll be things in there that'll reference the Julian date. Today is 2549017. So that's 2,459,017 days since the start of the cycle. And it will continue for again, about another 3,000 years. And then it'll recycle through again. It's something that a lot of people use. I'm sure many of you are familiar with it, but that's where it comes from. It's something that a monk within the Catholic Church in Italy during the 16th century calculated, and we find it incredibly useful today when we're doing astronomical work. So that's kind of an overview. Again, since it's independent of year and month, not moth. It is not independent of the moth. Okay, I'm sorry about that. But anyway, that's what you have for the Julian calendar. And that's pretty much my presentation. So maybe later I'll look at the Asian calendars, but I do appreciate the time, and I hope you picked up something. And if I did something wrong, please let me know, and I'll cover it later, I'm sure.
Thank you very much, Dan. I'm looking at the chat right now. I do not see any questions, and I did ask ahead of time if anyone has any questions. We'll go ahead and answer them at the end. I don't see any at this time, so I think we're going to continue. You can stop the screen share. I will actually, let's see. Oops. This is always fun, doing everything on the fly. So I will go ahead, and now I need to switch back to my presentation. Oh, here we go. We do have some questions. Mike Jones asking, how many calendars account for precession? Oh, whoops, hang on. I gotta flip it back. One moment. Okay, go ahead.
How many calendars count for precession? In the calendars that we're using right now, they even as early as Babylonian times, people were aware of precession, but it was not calculated in the overall calculations for a year, because they viewed it as a grander scale than the immediacy of doing a month in a year.
Okay. I think that's it. I don't see any other questions. So cool, excellent. Thank you very much, Dan. We greatly appreciate it. And now I'm going to switch back to my presentation. So this ought to be fun. All right, so to do that, this is always interesting because of my multi-monitor setup. Always this way. So one of my issues is getting this just right and moving it over. So everyone bear with me just a few moments and I will have it. For some reason also restarted me right at the beginning. So now I have to go all the way through. Couple more. I will probably end up cutting this thing out this little bit. So we've gone through presentation and now we are ready for club business. Okay, usually I have this at the end of our meeting. I want to go ahead and put this up right now. So if there are any board members who want to make any announcements, if there are any members who want to make announcements, any questions from the chat, go ahead and type them in now. And then after the club business, we'll go back to the chat and we'll answer any questions or talk about any topics that anyone wants to. So again, now is the time to put in your questions so that we can so that we can go in and go over them at the end. Okay. Next. Okay. I'm going to keep going over this every single time that we do a virtual meeting. So, or I have been, I should say. Our numbers are going up, and that's one reason why we're not having in-person meetings. This past weekend was the highest number of new infections in Texas since the end of March. That's not a good sign. So there are some indications that we're starting a second wave right now after the business reopenings. People are tired. I understand that. I haven't had a haircut in months. I could really use one, but I'll be honest, I'd rather have long hair and look kind of shaggy than have people get infected or me get infected because of my actions. So everyone has their part to do. Here are the numbers. Currently in the United States, as of this morning, we have 118,000 people who have died from COVID-19. This is more than the number of Americans who died in Vietnam. This is more than the number of Americans who died in the Korean War. And we just surpassed the number of men who died the American men who died in the First World War. So that kind of gives you a perspective on how many people are getting sick and dying from this. There is some good news. This morning there was a report out of England that a steroid is lowering the risk of death for people who are on ventilators and who are on oxygen. It is statistically significant, but it is not a miracle cure. On the plus side, it is rather cheap. So that news just came out. That's going out, and it's something like $5 a day for treatment. So a 10-day course, I think it's a 10-day course or 7-day course is 7-day course about $35. It is apparently not effective or not effective for people who are mildly ill, but only seriously ill. So we'll see what happens with that. But that was kind of interesting news that I saw this morning. So again, the virus doesn't spread itself; we spread it. So social distancing, minimize necessary contact, and please wear a mask. Okay, so virtual star parties are what we're doing. We're not doing in-person stuff. There's still too much of a risk. There may be some options that we can do. Small gatherings may be doable. Video astronomy may be doable in person. We would have to do some coordination. We may do like a test with a small group of people. We don't even know yet. This is something that we just talked about today among the officers. It's something that we'll look at in the next month or so, next couple of weeks, and see where we go. But for now, virtual meetings and virtual star parties. So this is from the end of May. I did a star party down in Grandview, Texas. There are much darker skies, able to see a pretty good view. And this is the Lagoon Nebula. So the skies are much darker down there than they are here in the city, and I've got power, I've got good internet. This is actually at my cousin's place, and it's better than the city, but there are some issues. It's only a 40-minute drive, but I kind of have to set up the night before to make everything easier. And right now, with the days getting longer and longer, I'd have to start the star party later. And what that means is starting at 9:30 or 10 o'clock instead of at 9. And a lot of people kind of want to start to get into bed at that time. I know that kind of do, but I think I started, I started at 9, almost 9 o'clock last time, and went on for about 4 hours. But we saw a lot of interesting stuff. Okay, Star Ranch. We are open for 15 people at the most, 10-foot separations, masks. My mask protects you, your mask protects me. And please don't share the equipment, clean or tag out any club equipment that you use. Thompson Foundation, again, no club use until further notice. They are working on plans for reopening. They are not ready yet, therefore we are not going there yet. Okay, again, all public star parties at Tandy Hills, Dinosaur Valley, and other locations are canceled, and there is no plan, no timeline whatsoever right now for restarting them. We don't have a date, we don't have anything, and I don't know why, but this is now out of order. That's okay. So this is again from the May, end of May star party, May 25th, I believe. So we were actually doing some lunar observing, which is kind of neat. So I was able to get a telescope on the moon, have a camera. We're able to look at various objects. And right now, I think I'm pointed, that cursor is actually pointed very close to the Apollo 11 landing site. Let's see, we need an update on the gate lock for Star Ranch access. So if anyone knows the situation with the lock, please go on to the e-group and let us know. Okay, so this is something I have a kind of a surprise for the club. One of the issues we've had with our solar telescope is the mount that it sits on. So it's a very, very nice mount. It's an equatorial. It's an Ioptron EQ45, I believe. It's a really nice mount, but it is equatorial. It does require it to be aligned to celestial North Pole, and it's kind of a pain to use. So especially when doing outreach stuff. So I found this not too long ago, and I managed to snag the last one that I could find. Everyone was sold out except for one last one. I managed to get it. So I'm going to talk a little about this. This is the Skywatcher Solar Quest. Neat little device. So one of the biggest problems we have solar observing, other than burnt retinas, is getting that proper alignment with a tracking mount when you can't align it properly during the day. So Skywatcher came up with kind of something interesting. It's called the Solar Quest Dedicated Solar Viewing Alt-Az Mount. So while finding the sun during the day might not sound difficult, precise alignment can prove surprisingly tricky because viewing the sun directly isn't possible with unprotected eyes. We have to rely on some indirect methods like shadows or a sol finder. With the Solar Quest, it's done automatically. So pretty much you press one button and it starts the alignment process, and in under 2 minutes, the mount's pointed pretty close to the sun. It's really, really simple. There's no hand paddle. There's no knobs to fiddle with. There's no polar alignment that you have to do the night before. You literally hit one button. So let's see. The mount head uses standard 3/8 threaded bolt, so you can actually just take the head off and put it on your own tripod if you want, or you can use the pier that it comes with and the tripod that it comes with. If you have a nice bigger one that you want to use, you can just use that. Just carry the mount head. It uses 8 AA batteries, and there is an adapter that it comes with that lets you swap it out for a 12-volt external power supply plug, standard center positive one. Really neat. That later. Let's see. So it's based on the Skywatcher AZGTE, but it's a totally different device on the inside. And there's no hand paddle like with the other one. So the only controls are the power button and an 8-way slider switch, and 2 LEDs tell you the power and the tracking status. That's it. You hit the power button, and then you wait, and then it works. So it can take up to 11 pounds for the optical tube, and eyepieces and camera, whatever you want to load on there. It's a standard Vixen mount. It's got one holding bolt. And when I put the Club Lunt 60 on there, it seemed like it was closer to the upper limits, but then again, it is kind of a heavy scope. So if you have like a 80 millimeter ED or an Apo with a white light filter, that should be okay. The Lunt it's a heavier scope. So what does it look like? It kind of looks like that. They have the tripod and the mount both have little spirit levels for leveling. It makes it pretty easy. The legs have these twisting lock collars on them. In the accessory tray at the bottom, you can see it just locks down and makes sure that the spreaders are positioned. And it's got rubber feet. So it dampens vibrations and it won't scratch anything or really get scratched. So once you've attached your tube, your optical tube, you hit the power button, and after about a minute to 2 minutes, it gets a GPS fix. So it knows time, date, where it is on the planet. And then the mount moves so the tube is now pointed directly at the sun. The sun sensor, that little camera looking thing right at the front, that centers the sun in the field of view, ideally. So solar sensor is basically like a little auto guider. It's a wide lens, just make sure that the image of the sun falls onto the sensor, and then the computer centers it as needed. There are guide cameras that cost more than this whole mount, so that's not bad. This one was calibrated at the factory, so didn't have to do anything really spectacular. When I had it with the Lunt 60 and a 16 mil Teleview Nagler, it wasn't exactly in the field of view, it was off to the side, but I could see the sun in the eyepiece, and I could easily center it. So once it was recentered, I just double-clicked the power button, and it reset the alignment, so it knew where it was supposed to be for next time. That's the fastest I've ever set up a solar scope in 2 minutes. I mean, it was ready before I had all my stuff ready. So it's, even when you're using like a simple manual mount, you still have to find the sun, you have to get it aligned, and then you have to keep track. And this was really, really easy. I was pretty surprised at just how simple this was, but I was pretty happy. You can see the standard Vixen mount, and you can see the camera where it is. So ease of use, again, simple setup. One button powers it on, aligns it, starts it track. There's no polar alignment, no hand paddle and cables, nothing, no buttons to press. It weighs just under 9 pounds for everything, so it's not terribly heavy. The whole tripod is about a 1.1 meters, another 220 millimeters for the pier. You can see the pier is over here, and the tripod and tripod legs extend out. You don't need the pier unless you want it higher. I just found it much easier to use it with the pier. So it folds down just like a normal tripod, just a little bit longer, and you just fit it easily in the back of the car or in the closet. The solar sensor, once it knows where it is and it points at the sun, all the tracking is done through the sun. You don't you use the 8-way slider switch to control it. You don't ever manually try to turn the gears. You can break it, so it's really easy. This is a really, really good tool when we start this up again for public viewing. It's really fast to set up. It's really accurate for tracking. So daytime outreach events are fine. You literally set it up. You hit the button. You align it. Once it's close, you center it out, and then you just get a line of people coming through, or we have a camera on there, send it to a laptop, keep it going. At $400, it's really, really cheap for what it can do. It is a very specialized tool, but we do a lot of outreach. Let me rephrase that. We did a lot of outreach, and we did daytime events. The couple of daytime events that I remember from last summer where we had the solar scope, it was a pain to set up. I know we had it at the UTA Planetarium outside. It just wasn't fun. So this will make it a whole lot easier, and we'll just be able to get not only a lot more people through, but the tracking will be much better. So for the Lunt 60, it was good. So there have been reports of small positional drifts for larger tubes, but for ours, it seemed to be fine for visual. I ran it for like 20-something minutes with video, and it stayed pretty close to the center. There was a slight drift to it. After 30 minutes, that's easily corrected, so it's fine. Battery life on the 8 AA's, it seems about 6 to 8 hours, and with the DC adapter, well, now you have a cable, but you don't have to worry about battery life anymore. You can just run it all day. Let's see. There is field rotation, but again, we're not doing any long-term photography with this video. I don't see field rotation as being much of an issue with video anyway. So overall, it's a very nice mount. It does exactly what it's supposed to do. No fuss, no muss. And it's really inexpensive compared to other astronomical mounts. Even if you look at some manual mounts, there are some that just alt-as manual mounts that cost more than this. They can handle a much bigger tube, but this is really nice for what it is. So I really expected to be able to do a daytime viewing in the last 3 weeks, and I have not had any time. So I'm going to try to make some time as soon as I can, if not later on this week, then this weekend, as long as the weather is good. I'll go ahead and have it outside during the day. I'll set up a calendar event and have that on YouTube and on Facebook, just a regular stream, and we'll go ahead and take a look at the sun. So I'll have it with the Lunt 60, so we'll be able to do hydrogen alpha viewing. Hopefully there'll be something to see. The last time I looked, there was nothing on the sun. We're at a solar minimum, no sunspots. There were a couple of prominences off on the edges. Nothing very big, nothing spectacular. But yeah, we are at a solar minimum. But I'm pretty happy with this. So, and I want to do this. So here it is. It's small. It's very, very lightweight. You can see here's the Vixen, rail, has the camera right there, and all it has is a power button. There's a power button, and the 8-way slider just goes around. It, it rotates, but it's just a slider. It doesn't click, it just moves over. So it's really simple. You have the base, so this part rotates down here, and the sensor rotates with the Vixen dovetail. And as it is right there, you can actually mount that on your tripod if you want. The pier is kind of neat, so it doesn't seem like much, but the top actually comes off. So this is where the mount goes onto, and you plop it down, you lock it down, just 3 set screws on all sides, and then you attach the bottom to the tripod. Tripod's in my office. I didn't feel like dragging it out right now. But again, it is really nice. It's very useful. Let's see. I don't see any... okay, I don't see any updates. Not too many updates in the chat, so we can go on. Next little bit. Let's see. Next bit that we have. All right. Elections. So this was an uncontested election. I've done 2 years. My term we have term limits, so I am done with being president. Congratulations, Michelle Thiessen. She is our new president for the next year. Long may she reign. Vice President Ed Gill stood in again, and it was uncontested. He will be vice president for a second year. Our secretary position was vacant, so we still need someone to please step up and become secretary. Some of the duties are being passed around to other club members, so it will not be a monolithic task. But yes, it would be very, very nice if someone would step. We have a run book with instructions on everything that needs to be done. Everything is going to go in there. All of our information, all of our data on online accounts, on what needs to be done, on processes for new members, everything we'll have there. John Giromini is again our treasurer. He stood in, so this is his second term. And then we have 2 new board members, Tom Roth and Cy Simonson. And Jerry Gardner is stepping in for the second year term for Michelle. She was a board member. So she has given up her board position to become president. Is that an upgrade? Is that a downgrade? Ooh, we'll find out. But congratulations, Michelle. And let's see. Next. Again, secretary, we need club members to serve, and the run book is available. So it will not be a grossly difficult task. It will not be a thankless task. We always, always, always appreciate all the officers' hard work and our board members in keeping the club running. So if you want to continue to contribute to the club, please help us serve. And I would like to say that it has been a lot of fun the last 2 years. I have really enjoyed being president. I thank you for the opportunity, for believing in me, and letting me do some wild and crazy stuff. It's been a lot of fun. I am stepping back, so I will not be involved in the operation of the club. It does take up a lot of time. I will help as needed, and I will go ahead and continue to do the star parties, the virtual star parties. I will continue to do outreach events. We will have to figure out how we're going to do the meetings, how Michelle wants to run them, but I will be available for support in whatever it takes. So I have the equipment, so we will continue to do this somehow. We'll figure that out over the next month for the July meeting. Okay, treasurer's report from John. We have $59,000 in the bank, $59,613. We have 133 members. 92 of you have paid. 41 of you have not. Now, please remember that the year started at the beginning of the month, our fiscal year. So dues were due at the beginning of June. If you have not paid, please pay as soon as you can. If you would like to continue membership, John will be removing your information from the Night Sky Network, I believe, next month. For any members who have not paid, you will also lose access to the e-group for information. If you do not want that to happen, please let us know. You can send a check to John. It is in the e-group, and you can also pay with PayPal. If you do not have the link, I will go ahead and post it to the e-group as well, so please check that out. If you do not have that information, if you're not in the e-group, please let me know. You can log into the Night Sky Network. You can find me on there and send me an email. Send any of the officers an email and let us know. We will show you exactly how to go through and pay dues. John also has mentioned that the AL payment is due June 30th, so that's however many active members we have who have paid their dues, that's the amount that we have to send there. And he is also looking again into, or more into, the Google Apps for nonprofits, so we can have a standardized repository for our documentation, so we can have living documents that are constantly modified as needed, as opposed to static documents like PDFs that are either on the website or in the e-group. Okay, so here, board announcements, member announcements, and questions from the chat. So I'm going to scroll quickly through the chat and see what I got. All right, so we have any news? Okay, Amazon Smiles now works on smartphones. So if you don't know, Amazon Smiles is a way that you can give money back to the club through regular purchases on Amazon.com. You just go to smiles.amazon.com, and when you log in, you'll be able to choose a charity or nonprofit of your choice, and you can look up Fort Worth Astronomical Society, and we're in there, and we will get a small percentage of your purchases. It's not extra. It's just what Amazon deducts from their invoice and sends it our way. It is not a huge percentage, but it does build up. Let's see what else. Updates on Star Ranch access. Okay, so there will be a new lock on the gate tomorrow. Same code as always. So if you don't know the code, please go on to the e-group. It is there. I will not give the gate code out over a YouTube video like this. The gate code is for members only. So again, please log on to the e-group and we have the documentation there. Next, let's see. All attempts at contact with UNT Health Sciences Center have gone without a response, including email, telephone, and fax. Okay, for those of us who remember, before the pandemic, we would meet at the UNT Health Sciences Center off of Camp Bowie and Montgomery in the Cultural District in Central Fort Worth. So they've been closed the whole time, and they could quite possibly be furloughed, the employees there. So they're not answering emails, they're not answering phones, there's just no one in the building. So we have no updates. We don't know when they're going to be opening back up. So until we get something, until we get recommendations from the CDC, from WHO, the World Health Organization, until we hear any good news, it looks like we're going to have to continue doing virtual meetings. That's okay. I will continue to support them how best I can, as long as it takes. So. What else? Mike Jones, I have the pier caps and telescope mount plans or plates ready to go for STAR for a while. Okay, so he's going to bring that. What those are is those are for mounting telescopes onto the existing piers that we have there. Instead of bringing a tripod, we have piers that are mounted in concrete. You have a pier plate on top. You put your mount on top. You put the telescopes on the mount. And it's fairly stable, and there's less for you to carry. I know with my tripod, it weighs something like 35 or 40 pounds. It is a pain to drag around and takes up a lot of room. So a pier would be nice. Okay. So, and what else? I got, and thank you, everyone. Again, I've really enjoyed being president. It has been a lot of fun. It's been some long nights. I'll be honest, I totally forgot the meeting was today. I thought it was next week. So my plan was actually to work on the website, get the presentation done this week, make it nice and easy after the last 3 weeks, and just try to get everything done on the weekend, and then relax on Monday, and then next Tuesday, do the meeting. And so, yeah, that didn't happen. Ed Gill actually reminded me late yesterday, oh, yeah, by the way, we have the meeting tomorrow. Are you going to run it? And so I had to do the presentation and get that done and put out the notices. I don't know if y'all took a look, but the notice went out about 12:30 this morning. So that was when I finally managed to get everything done. So this is my last meeting that I'll be running for a bit. I need this break, and maybe after a couple more years, I'll come back if anyone or if everyone wants me to do something else. But again, in the meantime, I will be no longer an officer, but I will be still helping with outreach events. And as much as I can, as much as I can find time to help out. Let's see. Gotta find where my cursor is. And that's all I got. So congratulations, Michelle. Congratulations, everyone who is becoming an officer or a board member. Thank you, and good night.